Hello, we are STEM-Best Robotics. We are here today to discuss our Simulink model developed for the Crossfire Challenge in 2017. The joystick read blocks are grouped into several sections based upon what functionality they relate to. The sections are drive inputs, shoot water inputs, gumball inputs, and Manny rescue inputs. The drive input section contains all inputs that relate to driving. The shoot water input section contains all inputs that relate to shooting water to put out the fires. The gumball input section contains all inputs that relate to controlling the system that feeds water into our launcher. Since the design of the system was based upon the mechanics of a gumball machine, the system was nicknamed Gumball. The Manny rescue input section contains all inputs that relate to rescuing Manny. The first subsystem in the processing section controls driving. This subsystem is also broken into three sections. The first section is where the initial processing of the data occurs. All inputs from joystick channels that will control the actual driving are first put through a deadband to ensure the joysticks output 0 when the joysticks are near 0. We next multiply our joysticks by a value to compensate for the loss of power from the deadband. The downside of this is that there are fewer values the joysticks can have that are low. The buttons are toggled here as well. Next, arcade drive values are calculated using the arcade module. Since our drivers could not decide whether they liked tank or arcade drive better, we implemented a system to toggle between the two drive methods. Also, to compensate for the loss in finesse from the deadbands, we implemented a method to toggle between halved and full speed. This allows for greater precision control. The next subsystem controls the water shooting mechanism. It toggles between full speed and stopped at the press of a button. The next subsystem controls the water feeder mechanism. This mechanism feeds water into the launcher through a system similar to a gumball machine's mechanism, as shown here. The subsystem has a system to toggle the position of the feeder every second between maximum and minimum positions. This motion can be toggled using a button as well, to close the feeder to prevent water from entering the launcher at inopportune times. The next subsystem controls the Manny rescue device. This system raises and lowers a system with a motor controlled by limit switches and a joystick input. The motor spins to lower the device unless the lower limit switch is pressed, or it spins to raise the device unless the upper limit switch is pressed, or, if both buttons are pressed, the device will do nothing. This system prevents the winch from unwinding, as well as prevents strange behaviors when both buttons are pressed. The data processed in the processing section is then sent to the output section. Here, the data is sent to motors and servos, and simulation outputs are displayed. This subsystem is broken up into the same areas as the input subsystem: drive, shoot, rescue, and gumball. The processed input data is fed into the actuators, and then into displays and a game field simulator so that outputs could be simulated and the model tested. Thank you for watching our Simulink video. We hope you enjoyed, and go Spartans!